Welcome to the 11th session on galvanic cells, and in this session we will be dealing with thermodynamic parameters related to the cell potentials, or you can say they are the thermodynamics of the cell reactions. So, we will recall some of the thermodynamic properties, mainly delta G, delta H and delta S. What is delta G? Delta G is a change in free energy, delta H is change in enthalpy, and delta S is the change in entropy. And as you all know, the free energy delta G free energy change. It is a measure of useful work, or you can say that what is useful work? A work which does not involve pressure volume change. Okay. And what is delta H? Enthalpy change means it is the change in heat content of the reaction. And what is delta S? It is entropy change, which is a measure of randomness, or you can call that to be a measure of disorder. Okay. So, these are the three thermodynamic properties which we are going to relate it to the potential of the cell. Now, let us go to the topic. Now, electrical energy is produced as a result of a cell reaction taking place within the cell, and these cell reactions, as we have seen so far, it does not have any change in pressure or volume. That is, you can say that there is no expansion contraction work in that, in the electrical work. So, it is gives us a direct measure of free energy change, and when if we are performing a process, free energy change of a cell decreases. So, when the cell is performing a useful work, its free energy change decreases, or we can say that electrical work is a measure of decrease in free energy. Now, what is electrical work done? Electrical work done is quantity of electricity passed through a cell multiplied by the potential difference, or you can call it as EMF. So, quantity of electricity into EMF will give you electrical energy. And how to get the quantity of electricity? We know that for one equivalent we have F Faradays of quantity of electricity, and for n gram equivalents, or if you are having n moles of electrons, n multiplied by F will give you the quantity of electricity passed through the cell. And of course, E is the potential difference or EMF of the cell. So, you will get this as minus delta G, which means that it is a decrease in free energy, is equal to the electrical work done NFE, or you can put it as delta G is equal to minus NFE. Okay. Now, just recall the Gibbs-Helmholtz equation. It is a Gibbs-Helmholtz equation which you have seen in thermodynamics, which goes as delta G is equal to delta H plus T into dou by dt of delta G at constant pressure. Okay. Actually, we have another expression, delta G is equal to delta H minus T delta S, and this minus T delta S is being substituted by dou by dou T of delta G at constant pressure. Okay. Now, I am going to substitute for delta G in terms of electrical energy in both the cases, that is on the right hand side as well as on the left hand side, both left and right. So, here we have minus NFE is equal to delta H plus T into dou by dou T of minus NFE by dt at constant pressure. Now, what I am going to do is I am going to take this minus sign to this side and open the bracket. We will have NFE E. Okay. So, multiplying by here it becomes minus delta H. Okay. Here we already have a negative sign of minus NFE plus this minus sign taken over here, it becomes again positive. I am writing it as dou by dou t of NFE. I have taken the negative sign out. With the negative sign coming over here, both makes it positive. Okay. Now, I am going to take this NF also outside the bracket. You can have this expression as NFE is equal to minus delta H plus NF and the T which was here multiplied by dou E by dou T at constant pressure. Now, what is dou E by dou T? It means that small change in EMF with temperature. So, change in EMF by change in temperature. This factor, if temperature increases, then EMF increases. Suppose if it is so, the value of dou E by dou T will be positive. It will give a positive value, that is the value of dou E by dou T at constant pressure, it will be positive. When temperature increases, if the EMF is decreasing, that means one increase, the other one decreases. So, that will give you a negative value for dou E by dou T. And if temperature changes and if there is no change in EMF, you can call that to be 0, that is neither positive or negative. Okay. Now, let us go for the explanations. Dou E by dou T, that is change in potential with temperature, is known as temperature coefficient of EMF of the cell. Dou E by dou T at constant pressure is known as temperature coefficient of EMF of the cell. Now, we are going for the explanations. If dou E by dou T at constant pressure is positive, remember that is when there is an increase in temperature, there is an increase in EMF, the electrical energy will be numerically greater than enthalpy of the cell. Just note that it is numerically. Okay. So, this is the electrical energy. Okay, this is the enthalpy of the cell reaction. Now, here we are having dou E by dou T at constant pressure, it is positive. That means that you do not consider this negative sign, you take the numerical value of delta H. To delta H, I have to add this value because this will be positive, only then you are going to get the electrical energy. So, why does it happen so? Because delta H is lesser than electrical energy, you have to add something else, only then it becomes equal to electrical energy. Now, that is what is explained here, that is if it is positive, electrical energy will be numerically greater than enthalpy of the cell reaction. Now, take the case when it is negative. Negative means that is electrical energy, I will put it as here electrical energy and here which is equal to minus delta H, or I will put it as enthalpy. And here we have a factor NFT and this is the temperature coefficient dou E by dou T at constant pressure. Now, when this is negative, this term will be negative. That means that from enthalpy I will have to subtract something, only then that will be equal to electrical energy, or you can say that enthalpy will be numerically greater than electrical energy. So, electrical energy will be numerical or in the vice versa numerically less than enthalpy of the cell reaction. Okay. Now, if both are equal, that is when dou E by dou T is equal to 0, you have electrical energy exactly equal to enthalpy of the cell reaction. Okay. Now, under standard conditions delta G naught, just put a naught over there, delta H naught plus T into dou by dou T of delta G naught by dou T at constant pressure, and substituting we will get it as N f E naught is equal to minus delta H naught plus N f T. For dou E by dou T you will have an E naught instead of E at constant pressure. Now, how to calculate the thermodynamic parameters? Now, here we are having the electrical energy and enthalpy of the cell reaction relation, but how to find out the delta G, delta H and delta S in cell reactions? We know that delta G is equal to minus N f E. So, there is one relation you are having with the cell EMF and the free energy change, which is a thermodynamic property. Now, we know that N f E is equal to minus delta H plus N f T into dou E by dou T at constant pressure, which we have derived earlier. Now, I am going to take this delta H to this side, okay, and taking N f E to the other side. Now, with delta H, when it comes to this side, this becomes positive. Delta H is equal to, okay, this we have N f T into dou E by dou T at constant pressure, okay, and when N f E goes to the other side, it becomes negative N f E. Okay. So, you are having common factor, that is N f is here. Here also you have got N f. So, I can take that common factor out. This will be N f into T into dou E by dou T at constant pressure minus E. So, this is the delta H. Delta H is equal to N f into T into temperature coefficient minus EMF of the cell. You will have to by heart all these, because you require that for solving problems. Okay, delta G is equal to minus N f E, delta H is equal to N f into T into temperature coefficient of EMF of the cell, that is dou E by dou T at constant pressure minus E. Now, we will have to see the relation for delta S. Delta G is equal to delta H plus T into dou by dou T of delta G at constant pressure is a Gibbs-Helmholtz equation, and in this what I am going to do is I am going to substitute for delta G, that is on the right hand side alone. Okay. So, I can put this as delta G is equal to delta H plus T into dou by dou T. Instead of delta G, I am going to put it as minus N f E. Okay. You have N f here, minus N f, I am going to take it out. You will have delta G is equal to delta H minus N f T into dou E by dou T at constant pressure. Okay. Now, I am putting this as equation number 1. Okay. Another Gibbs-Helmholtz equation, that is delta G is equal to delta H minus T delta S, let that be equation number 2. I am going to compare these two equations. See, here we have got delta G, this is also delta G, here we have delta H, here we have got a T over here and a T, with both are negative terms, and when we compare these two, you can say that is delta S. In this term we have delta S, and excluding this T we have here N f and dou E by dou T at constant pressure. Okay. So, I can say that delta S, because both are negative, you can put it as delta S directly. Delta S is equal to N f into dou E by dou T at constant pressure. So, this is the another relation. So, delta S is equal to N f into dou E by dou T at constant pressure, or if you remember that dou E by dou T is the temperature coefficient of EMF, then you can just relate it as delta S is equal to N into F into temperature coefficient of EMF. easy to remember. Okay. Now, let us go for the problem. You are having all the 3 thermodynamic properties related to the EMF of the cell. So, next we will go on for the problem. The EMF of the cell cadmium chloride with 2.5 H2O molecules in a saturated form in contact with AgCl solid and Ag. Here we have cadmium chloride in a saturated solution of 2.5 H2O. Okay. Now, the EMF of the cell is 0.6753 volts and the temperature is 298 Kelvin, and 0.6915 volts when the temperature is 273 Kelvin. Okay. And they have given the cell reaction, that is, the cell reaction is cadmium solid combines with AgCl and some this aqueous stands for water molecules to give cadmium chloride 2H2O, H2O in a saturated condition plus 2 Ag, and this equation is given for us to determine the value of N. Calculate delta G, delta H and delta S for the cell reaction at 298 Kelvin. So, the temperatures are very important. You have got the voltage for cells at 2 temperatures, that is at 298 as well as 273, but the thermodynamic properties we require is to be at the temperature of 298 Kelvin. Okay. So, I am going to write down the EMF 298 Kelvin is equal to 0.6753 volts. At 273 it is equal to 0.6915 volts. Now, here I have put it as N is equal to 2, but we will have to verify it. Okay. We know the cell reaction cadmium solid plus 2 AgCl plus aqueous, that is some quantity of water, it means cadmium chloride. Here it is 2.5 H2O in a saturated condition plus 2 Ag. This is the cell reaction. Now, let us see what is happening here. This cadmium is in the elemental state, its oxidation state is 0. It changes to cadmium chloride. You know that chloride is with -1 oxidation state and you have got 2 chloride ions, and therefore, the oxidation state of cadmium is +2. Okay. Now, AgCl, in AgCl the oxidation state of Ag is +1, but you have got 2 Ag ions and therefore, it makes a total of 2 plus charges for this 2 Ag. Okay, 1 Ag you have +1 and 2 Ag it will be +2, and it goes to the 0 oxidation state of elemental state, that is Ag. Now, in both cases you can see the changes from 0 to +2, that is 2 electrons are removed. Here from +2 state it goes to 0 state, that means you have added 2 electrons, and that is how we identify the value of N as N is equal to 2. Okay. Once we get the value of N, you can find out the delta G value, that is delta G is equal to minus NFE, and remember the temperature has to be 298, and that is why I have given this as subscript. It is 298. So, E also has to be taken the value at 298 to get delta G at 298. N is equal to 2, F is equal to 96,500 coulombs multiplied by EMF of the cell at 298 is equal to 0.6753 volts, and volts into coulomb is joules. Therefore, the answer will be, just calculate it using a calculator, you get it as minus 130,332.9 joules. Okay. Now, this is delta G, and next in the derivation we have been considering delta H first, but while doing problems we will first find out delta S, because the entropy change, it is a smaller equation and for delta H this is a bigger one. Okay. So, what I am going to do is first I will find delta S, and for delta S the expression is NF into temperature coefficient dou E by dou T at constant pressure. So, smaller one. So, the calculation will be easy. For that first I will calculate dou E by dou T at constant pressure. Now, these are the EMF values at two different temperatures. See 0.6753 minus 0.6915. Here one more point to be noted is that when temperature is greater, is 298 is a higher temperature, and the EMF, what is it? It is again a higher value or a lower value. It has got 26915 volts. This has got a lower value. Okay. So, what I am going to do is I am going to subtract it in the order, that is from higher temperature minus lower temperature. Otherwise, the value of dou E by dou T will not be negative. Or you can do it the other way. When temperature increases, since the EMF is decreasing, you can say, you can calculate the value and then say the value should be negative, because as temperature increases the EMF is decreasing. Saw it 273.69 and it is 0.67. Okay. So, what I did is I have taken the lower value first minus, because this is at the higher temperature minus that of lower temperature, it will give you a negative value automatically divided by 298 minus 273. This will be positive while this will be negative, and the total result will be a negative value minus 6.48 into 10 to the power minus 4. These are volt and this is temperature. So, that is volt per Kelvin. So, dou E by dou T is being calculated. Now, you can calculate delta S, that is N into F into the value of dou E by dou T, that is minus 6.48 into 10 to the power minus 4, and the answer will be on calculation minus 125.04 joules per Kelvin, because this is coulombs, this is volt per Kelvin. Okay. So, coulomb into volt makes it joule per Kelvin. So, that is the answer minus 125.064. So, whenever you get a problem, do not go for the delta H first, first find out delta S, because calculation is simple in the case of delta S. Okay. Once you get delta S, we need not go for the complicated expression. We know that delta G is equal to delta H minus T delta S, that is a thermodynamic relation. Okay. Now, from this, if I put it as delta H equals delta H, I am retaining it here, I am taking minus T delta S to the other side, we will get delta H is equal to delta G plus T delta S. Okay. We have calculated the value of delta G as minus 130,332.9. Okay. Then what we need is T delta S, T is 298 Kelvin. Here also you should remember you have to find out the value at 298, and therefore, I am taking the value of delta G also at 298. This is also at 298. That should be taken care of, so that the answer does not go wrong. Multiplied by minus 125.006, that is the entropy T delta S and just it is a simple calculation now, otherwise it will be a tough one, and the answer is minus 167,601.072 joules. Okay. So, whenever you get a problem, first find out delta G and then go for delta S, and from the relation delta G is equal to delta H minus T delta S, you can easily calculate the value of delta H. Okay. Now, to conclude, delta G is equal to the relation delta G is equal to minus NFE, that is decrease in free energy is equal to electrical work done. The electrical work done is NFE, and taking the negative sign to this side we get delta G is equal to minus NFE, where N is number of electrons involved in the cell reaction, F is the Faraday 96,500 coulombs, and E is the EMF of the cell. Now, NFE is equal to minus delta H plus NFT into dou E by dou T by substituting the delta H values by NFE, and dou E by dou T is known as the temperature coefficient of EMF. The temperature coefficient of EMF, if it is positive, the electrical energy will be greater than the enthalpy of the cell reaction. Dou E by dou T, there is a temperature coefficient. If it is negative, electrical energy will be less than the enthalpy of the cell reaction. Dou E by dou T, if it is equal to 0, that is when temperature changes the EMF does not change, that means the electrical energy will be numerically equal to the enthalpy of the cell reaction. Next, we have been seeing the relation between delta G, delta H and the cell potential. Delta G we have already mentioned it, delta G is equal to minus NFE, while delta H I told you it is a complicated one, it is NF into T into dou E by dou T at constant pressure minus E, while delta S is equal to NF into dou E by dou T at constant pressure. And remember, while doing problem, we will first calculate delta G, then delta S, and delta S we will not be using this equation, we can use this equation delta G is equal to delta H minus T delta S, and from this we can calculate the value of delta S. That will be a simpler method for doing problems, and that is all for this session. Thank you.